Hello and welcome to my talk on large language model powered applications. My name is Aaron Celeste. I will be going over several topics during this talk. One of the main topics will be Langchain. Langchain is a framework which can be used to develop large language model powered applications. At the end of this talk, I'll be giving a demo of some Python script which makes use of Langchain. There are other frameworks besides Langchain, of course. There's a list of them. Pick some examples. This diagram is also a bit of an overview of what I'll be talking about. So generally, this direction of flow here is counterclockwise, as you can see, starting with the user, inputting text, and then ending with getting text out. But of course, if you develop some tool, you can have it be other forms like the user clicking buttons, and the information going back to the user could be whatever you want. But at least for the LLM part, as we know, that's going to be text in, text out. And then, so documents going in, that could be if you want your Langchain program to use a database of text that the large language model has not been trained on. If you want to ask a large language model about some like private documents or something, then that's this documents going into Langchain. So the embedding, as we saw earlier with the past presentations, this is vectorizing text. And that is useful in this example that I gave, where you want to ask a model about documents that the large language model were not trained on, for example, your private documents. One way to do this is to do a similarity search, comparing your query with chunks of your private documents, and then only sending those to the large language model. And the reason you would want to do that is because processing a large amount of text for a large language model is super expensive. So you only want to send a subset of the information to the large language model. And vector storage can do that for you. So after you vectorize text, then putting it into a vector database will allow you to do this kind of similarity search, which I'll talk about more in detail later. Yeah, so agents, very interesting. It's a feature of Langchain, for example, where an agent will engineer a prompt to the large language model, telling it that it has the power to use specific tools, and then the large language model will get the output from those tools, and then it's able to do that multiple times. So this area here can be sort of in a loop for a while until it completes the task, and then it'll continue. But again, more in detail later. So vector embedding. As Himanshu talked about, you can make text into these lists of numbers, and these numbers are features of the large language model. And this list of numbers will together encapsulate the semantic meaning of the text. So like the meaning of a sentence will be transcribed into this list of numbers. And early, as I was learning about this, I thought maybe that meant each feature was some sort of concept like positivity versus negativity, or like formality versus like personal versus professional, or something like that. But there's not enough of these numbers. In the case of OpenAI, one of these vectors is only like 1,500 numbers. And so it's not that each of these numbers represents one of the concepts, it's that the whole list of numbers itself together represents all of the semantic meaning of a piece of text. So of course, when you vectorize a piece of text, that's going to be specific to the specific model. Also works on images. So in an image, you may have similar sorts of concepts like positivity, negativity, etc. All of those semantic meanings of a sentence, you can prescribe each of these features a number for a particular image. So that's how these large language models can work by they can sort of read images and get the meaning of them. So in a vector database, the vectors, these strings of numbers, are like plotted. If you do a similarity search, then you can plot these vectors in high dimensional space, where each number is a coordinate in like super high dimensional, like 1000 dimension embedding space. And it's easy for these vector databases to compare the distance from one vector to another vector in this embedding space. And so that's how you can get how similar the meaning is of one piece of text to another piece of text. And there's some examples. There's a Pinecone is one popular for industry, where Pinecone is one vector database, which is very scalable and very quick with these similarity searches. But Chroma is an open source vector store where it has a bit more variety of searching features, but it's not as scalable or fast. These similarity searches are not new. Back in the 90s, these were used for search engines. So where you're comparing the distance of these vectors in this high dimensional space, that same sort of thing has been used for a long time. Yeah. So this is as the example I was giving earlier. So if you have a whole bunch of documents that you want to ask a large language model about, you can split it into smaller chunks, get vectors for each of those chunks. And then when you ask a query to the large language model, first, before you submit it, you can get the chunks which it has the most semantic meaning to first, and then send those chunks along with your query. And the large language model will get the context and get your question, and then be able to respond about it. So this is an example of the OpenAI API. This is an important part of building these large language model powered tools. If you're going to use OpenAI, for example, I just wanted to show on the right here how easy it is. You literally just import OpenAI, define a variable, and then you can print the output of a function where you input your query, and it'll give you the response from the model. Hugging Face is a large language model provider as well that's free. But for OpenAI, for each of these requests, you're going to be paying. So Langchain, this framework that helps you build these LLM-powered tools. So it's kind of a man in the middle between the user and the OpenAI API if you're using OpenAI. So it can be used with many different kinds of large language model providers like Hugging Face and others. But most of the features are just prompt engineering. So I'll talk about that a little bit with agents and memory, but a lot of this stuff you can kind of do if you open up ChatGPT. You can sort of get a lot of these features yourself by tediously copying and pasting things or adding chunks of documents, but it can be very powerful to not have to do that. And so that's where these frameworks come in. So where the name comes from, this chain idea, is having chains of these commonly used features. One example would be if you wanted to get a summary of a large piece of text that was too big to send all at once to a large language model. One way you can do that is split it into smaller pieces, and then ask for a summary of each piece, and then submit all the summaries, and then ask for a summary of the summaries. And so these frameworks like Langchain can be useful because you may just have that on one line of code where you say, here's a huge piece of text, give me a summary, and then it does all of that in the background, chaining together these sort of modular functions. And what's cool about Langchain is that you not only have these nice one-liners, but you can also split them up into their module pieces and then build your own more complex, customized versions. Yeah, including, as I said earlier, with these agents, where the agent is telling the large language model to make a plan and then execute the plan step by step, and maybe even troubleshoot if something along the way goes wrong. So you can get that on one line of code with this Langchain framework, but then you can also split that up into pieces and customize it. So you can nest agents in other agents, giving agents the ability to spin their own agents. Yep, as I've talked about a bit already, telling the large language model you have the power to use tools. What that looks like in your code is you define a function, and then the agent will tell the large language model about your function. It's super easy. There's like this little space for you to put a description of what your function does. And so along with the prompt engineered system that the agent is working with the large language model, it's going to send a bunch of context in there. It's going to say, hey, here's one of your tools. Here's a description of it. And then the large language model will be able to say, okay, in order to accomplish step one, I need to use this tool. So I need to include in my response, which is JSON formatted perfectly, like use this tool, input this into the tool, and it can do all of that automatically. Yeah, and the wild part to me is that it's also troubleshooting. So when you use a tool, for example, a tool that can just execute Python code, the output of the tool will be sent back to the large language model, and it will see that output. And if it was an error, then it can think, okay, how can I try that a little bit differently? So that's pretty crazy for me. And there's different variations of agents within Langchain. So there's agents that strictly adhere to a concrete plan after they make it. And that's useful so that it doesn't get lost along the way. But then there are other agents that will kind of go more with the flow and be a bit more creative to get to the end goal. But those may sort of lose the plot along the way. And so one way to use these together is to nest them and say, your top level agent is the concrete one that makes a plan and sticks to it. But then it has a tool that spins up a more creative agent. And if that fails, it can just try again.
Oh, yeah, that's good.
Yeah.
So what you're saying is that the agent will use a kind of a trial and error approach for debugging.
So the agent sends a ton of context to the LLM.
Yeah.
So the LLM just gets a bunch of information, and then it decides what to do and sends a little bit back to the agent that just says, agent, execute this tool with this input. So the agent is just the agent is the dumb part. It's just like forwarding.
Okay. Oh.
The agent is just forwarding like a bunch of information to the model, and then the model has the ability to get the output of running its tools and make a plan, and it just runs in a loop until the LLM decides that it's done.
How many agents are there in Langchain?
There's a ton. I'm gonna give two examples. One that's specialized for CSV editing, and one that's a general Python executor. So that'll be fun in a minute. Yeah. Oh yeah. So then you can also append features like chat capability to these agents so that the user can follow up about like, how did you solve this, for example? So Langchain makes stuff like that really easy. Here's another block of code. I just want to show how short it is. This is how you spin up an agent. And so you can define each of these things very more customizable. So here I'm just saying, give me the generic tool, the thing that lets it execute arbitrary Python code. But you can also like have a list of functions where you define your own tools. Yeah, and so again, I'm literally just printing the output of this function as with the OpenAI API. And in this case, it's a very much experimental tool. And I noticed that giving it a little bit more context resulted in just more success. For example, this funny part at the end, whenever you give me code, add a hashtag to the end of it. I noticed that somewhere in the transcribing of the code back and forth between JSON, the LLM was accidentally like knocking off the last quotation mark sometimes. So I fixed that by just adding a hash, I didn't add anything. I just told the LLM, add a hashtag at the end of your code, and that sort of fixed it. But I thought that was funny. A little bit about memory. Large language models don't usually by definition, remember the last question you asked, but how you can build that in with something like Langchain is there are a lot of options to do that. But basically, you just submit with each query a history of your previous queries. And there's a bunch of ways to do that. There's these 4 that I'm highlighting. Window memory would be where you only send a few of the last queries, so that way you don't get too expensive in how much text you send. There's also summary memory, where you could send a summary of the previous queries, and also token memory, where sometimes the way the large language model provider will charge you, for example, OpenAI, is by token, which are roughly words. And so you can have a memory that is sensitive to how many tokens it's using up. And yeah, as I said earlier, like even these agent things, it's all just prompt engineering. So it's always just text into the LLM, text out. What kind of text do you put in? How are you harnessing this intelligence? Talk a little bit about Playground. So OpenAI has this web page that can be useful for developers. I'm going to show it to you, actually. All right, so the way you find it is you go to OpenAI, sign in, and at the top there's just this Playground tab at the top. All right, so one way this page can be useful for developers is if you are embedding specific text as prompts in your application. It can be useful to engineer those prompts to be giving better, more sure responses. And so one way you can get that information off of this page is by going into the complete mode, scrolling down and finding full spectrum. Awesome. Okay, so now that we're in this playground area, one way to use this, if you want to see if your prompt is going to generate responses that the large language model is more or less confident about, you can use this feature, which is complete. So I'm going to input some text, and then it's going to try to complete the text. And then in theory, it's going to give me colors based on how confident it is. So if we ask it a question that it should be confident about, this has a concrete answer. What's the capital of the United States? And we get a pretty green answer. Green means that it's very confident. And we can ask it something that it may not be confident about. Write me a poem about fish. And it's much less green. So there's definitely some less confident parts of this. And as Himanshu already discussed, we have a bunch of different options here. So for example, we have temperature. So lowering the temperature is going to make it, less creative. It's going to make it deterministic. If you bring this all the way down to 0, it should be deterministic. So it should output the same thing every time. So if we try again with temperature as 0, we can see it's much more green. So it's much more confident about the answers.
I want to ask a question.
Yeah.
I mean, asking this model to write a poem is something creative.
Mm-hmm.
And there is not any meaning with colors and confidence, right?
Well, if it's more creative, yeah. So
You can do another.
How about the same prompt with 100% temperature?
right. So then it goes totally wild, actually.
It's going to be about fish and all.
No, it's not going to be about fish anymore. So this is when your temperature is too high.
Can you read it aloud? I can't read it.
I can sure try. There's some non-English letters here. Colnweir ex disognu swats is thoughtful. So that's a high temperature. And the interesting part is back in the code, you can set this. So like in your code, you're going to be able to, when you define your OpenAI variable, you can say temperature. So that's going to be very easy. And then another one of these concepts that Himanshu went over already, top P, that's going to be for each word that the large language model generates, it's going to be grabbing a word out of a set of possible words. And if you put the temperature to 0, it's going to grab the word with the highest probability, the highest confidence. And the top P controls from which of those does it even consider. So if it's looking at a set of words, the top few have a high probability, but if you have a high temperature, it may select one of the lower confidence ones. And if you have a top P of 0, it's only going to consider that highest confidence word. And so we can see that if we set top P to 0, and we put the temperature all the way up, it shouldn't have gibberish here because it should only consider the highest confidence. What?
Oh, this is the same old poem.
Right. And so it's no longer gibberish, even though the temperature is ridiculous, because the top P is 0, which means it's only considering the highest confidence word. So you can set all of these in your code as well. Yeah, and so how this can be useful to developers would be if you want to include text that is more regularly going to produce more confidence, then you can fine-tune these things and see how green your responses are. All right, so that was our OpenAI playground. We had temperature and P. Very good. So I'm going to do a demo. I'm going to show you some code that's going to run some of these Langchain features. You can have the code too if you want. There's a QR code. It's going to be also on the ending slide, so don't panic if you don't get it now. So first, large text processor. All right, Langchain demos. So let's try the large text processor first. So I've included my master's thesis in here. And if you were to send all of this to a large language model, it would say, absolutely not. I'm not going to process all of this. It's too much. And so what if we want to still ask a large language model about all of this text? So one way that you can do that is by using Langchain and using vector storage. So as I discussed earlier, it's going to split this text up into smaller chunks, send them into a vector database. In this case, I'm using Pinecone. And you're going to want to include your Pinecone API key in here. And in this code, I've made it work with both OpenAI and Hugging Face. So if you switch this variable over, then it's going to use this free version. But right now, I'm going to use some sweet money to run this and send it through OpenAI. Yeah, so you can see it's only 100 lines. All right, so I'm also using something called Streamlit, which is a way that you can sort of show proof of concepts of apps. So it's going to actually open this up in a browser. All right, so this is already attached to my thesis, and we can ask, like, what's this about? So right now it's splitting my thesis up into chunks, sending them to Pinecone, vectorizing all of those, and then doing a query about the similarity of my query with each of the chunks, finding the chunks that my query is most similar to, sending all of those to OpenAI, and getting a response. So it says this chapter. Okay, that's not the best response. We can try again.
What is point?
Yeah, good idea. This thesis project, wow, that's much better. Try again. Yeah, so I've done this much. It seems to do a pretty good job most of the time. I can ask, so it's about building a tool, you can see. So I can say like, is the tool parallelizable? Spelled wrong. We can see how it does on that question. Yes, it's parallelizable. Amazing. We can ask, what are the pros and cons? Using a batch size of 1. Okay, that's very specific. What are the pros and cons of this tool?
Now you're not sending context, right?
Well, it's sending the chunks of my thesis that are most similar to my question.
Yes, but you have no history.
Yeah, right. No history. No, yeah, there's no chat or memory here. But the thesis is all about my tool, so it should know the tool. But yeah, so here it's high quality training data for machine learning methods like segmentation. That's perfect.
But if you ask something that is not even the generate,
What it is going to give some.
yeah, that's what I'm saying. It is going to generate things, but it won't be based on things.
Let's try what color is a strawberry. So Rohit asked, what if I ask about things that are not about my thesis at all?
No.
That's pretty funny.
Better than humans would.
There's less hallucination here, I think, because
Ask like something.
Who is Rohit? Can you ask?
It will give them.
Who is Rohit?
so I think the reason it's not telling us what color strawberry is because in the prompt that has been created by Langchain, it says.
Oh, see, correct answer.
But if you ask something like, can cogs be used to train machine learning model for face recognition? Does it give some face recognition?
I think it's.
It should give something, right? Not, I don't know.
Because segmentation
But
is there.
Yeah.
That really requires thinking.
Not useful. Woo! Excellent. So I think the reason it didn't say what color strawberry is because in the prompt it said something like, if you can't find the information here, then say you don't know. I think it actually explicitly says that.
It is taking context of the internal document and what GPT knows about the word. So for example, it took codes from what codes does and what basically the human recognition system is, and then
Can you ask write a biography of Arun Celeste?
yeah.
maybe during the break.
Okay. Just please move to the next app.
Yeah, so let's see what we got here. So we have 2 more to go through here. We've got General Python agent, which is the coolest. I'll save that for last. We have CSV manipulation. So again, very short. It's only 30 lines. It's just using one of these pre-built Langchain functions here. So it's just creating this particular kind of agent, this data frame agent. We're setting the temperature very low so that it's producing very accurate code and stuff like that. So it's less creative with the code. All right, and again, this is on Streamlit. Right. So we have to upload our spreadsheet. It's going to be this employees one. We can have a look at it. Oh, that's not the right spot. Oh boy, that's Chinese.
The characters in PDF.
Yeah. it's like-
Awesome.
yeah, there we go.
Thank you. So this is just dummy data. So we can see, like, if you have a spreadsheet, maybe you want to clean it. Maybe you don't know how to use Excel very well. Maybe you don't know how to make these formulas. Maybe you don't know how to write code. Maybe you're in biology or something like that, and you just want to like. I'm saying, like, you're not a computer scientist, right? You want to like clean your data. I'm not saying biologists don't know, but just an example. So I can say something interesting like, so I can say like, if the last name, yeah, so I can say like, if the last name starts with a S, then let's oh no, if the employee ID is between 200 and 205, then change the last name to Smith, for example. In here. And I already know that I've done something wrong. I should have told it to save the file, actually. So it says it has been changed. Amazing, but yes. Oh yeah, and we can also see this happening in real time. I should have showed that for the other one too, but so we have so it's at, I don't know, I don't want to go through this so much right now, but let's see if it worked. Updated. That looks pretty good. So we can already see 200 employee ID Smith. Pretty cool. And all the way to 205 is Smith. Yeah, and then if I go back a bit to our other demo, so these are all of the chunks that it recognized were similar to my query in the last demo. So it was just printing, like, kind of interesting to see. So it was working with chunks of text this big when it was answering the previous. And you can customize in the code how big you want these chunks to be, how many of the chunks do you want it to send, all of that. So that one worked. We can say if the we can ask it to add a row of synthetic data, for example. We can see it working in real time. So I need to import pandas. Whoa. Some of this is very interesting. So it's like, what's the first one? Here's the first one. So it's like, I need to import pandas. So the first thing it does is import pandas. And then the next thing, I can use that to append a fake row of data. And then here's the.
His cell phone number is 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, exactly. To add a row of fake data. And then here's the code that it's trying to run. Append this row. And then there's some warnings. That's always fun. But that looks like it's fine. And then I've added a row. Oh, and then it saved it. Very good. df.csv. Let's find it. And it's df.csv. That's the one. We should be able to see at the end. Is it that Joshua? John Doe. Oh.
I don't think it will show all the rows of data.
Maybe that's what the warning was about. Maybe it was like in place is equal to true or something. It forgot to do that.
All right, let's try again then.
Yeah, there's John.
Is he in there? Yeah, there he is here.
This process is very human-like, right? That's also.
But if it doesn't work, you can just say, do it again. Then we know where to look for it. Let's see. So now it's trying again, another John Doe. And it saved it as a new file. New file. Oh yeah, John Doe. Woo! Excellent. And so we can see it's like the data is pretty, it's consistent. It's like 2,600 for this salary amount. So this can be useful, as you can see. Although sometimes I've noticed the employee ID is a duplicate. Yeah, 203. Yeah, 203. So you got to be careful with your fake data, but yeah, so that's a cool one. Moving on to the third demo of the arbitrary Python code executor, my personal favorite. All right, let's do that one. So that one is here, super short, as I showed on the previous presentation slide. It's one small change. Instead of having a hard-coded question, it's going to ask us what question we want. Why? So we can do simple things like save an empty text file to the desktop. So it's going to say, I need to import OS for some reason. And then something, whatever that is. All right, so it says it did it. Let's see if it did it. Oh my gosh. What's the name of it?
Test.
Is it test? Excellent. All right, let's look for test. Oh, test.
There it is.
It's empty. Very good. All right. So we have test. We can ask it. That's not right. I'm gonna do that. We can ask it how many words are in my thesis. Whoa. Okay, let's try that again. It's still doing something, actually. It's counting, yeah, it's going through. Yeah, okay, so OpenAI says no. Let's try again. And of course, like changing the temperature is going to change if you get different results. So here I have set the temperature to 0.5. So it is being creative. It's definitely going to be a different result each time. And I did that intentionally. I want it to like try different things because sometimes it just doesn't work. Is it doing something? No. Okay. So now it's getting a bunch of errors and it's troubleshooting in real time. Terminal is not a valid tool. Good to know. So it's not allowed to use my terminal. Yeah, exactly. So you can see it like changing this code that it's trying to run each time, slightly.
So not giving the connection.
No, it should be. These are all observations. These are all outputs from trying to run the code that it submitted, and each of these thoughts, each of these action inputs. Yeah.
I think thankfully it's not allowed to run sudo.
That's good.
And I think that might be the error here.
That's good.
You should press sudo Python 3 once. Just watch it destroy the code.
Yeah, so it gets things wrong, but again, that looks like the same error actually. Yeah, okay, interesting. Anyway, we can ask it to do things like plot 1,000 points randomly in 3D with a normal distribution, and then visualize it. Let's see. This one is very hit or miss. Hey! Excellent. Yeah. So it does things. We can ask it to cook a potato. So it's so it's waiting, it's cooking. Let's give it up for this agent.
We're going to have a snack now.
Imagine him just starts eating a few.
All right, let's get in this. Oh boy. All right, quick warning. One time it installed something on my computer. So I told it, I asked it how many words were in my thesis actually. And at some point it said, yeah. No, what? There, okay. So it said, you can see my mouse.
And I installed that this time as well.
Oh, great. But this time it worked. It installed this PDF plumber, and now it's on my computer. So if you ask it to do something, depending on what version it chooses, you know, from 2021, it can break things. So fair warning. Yeah. Thank you very much.
Any questions?
Can I have my potato?
Yeah, where's the potato?
Okay, thank you, Aaron, and thank you for coming today. We'll
It's
start
still going.
tomorrow at 9:30 in the morning. So I hope you guys are here again tomorrow. We'll have a lot more topics tomorrow, and it's going to be a good day tomorrow. Thank you again for coming.
Hey, there's the potato. It just finished. Perfect.
That was fast.